No, I didn't actually. I even had to uninstall everything I did before because I was writing a test and the testing software
Mm-hmm.
wasn't letting me like write.
Okay.
So I even uninstalled a lot of things. So yes.
Okay. So let us start from the scratch again. Because there is no use of going high level or like going advanced. So, were you able to like grasp whatever we discussed in the last week in the presentation or not? In case it's not, please let me know not. In case it's okay, please say okay. No problem at all.
Last week I wasn't here, so I was gonna watch it. I was here the first week, so I installed the Git.
Oh,
And yeah, so I wasn't here last week and I didn't watch it. So if it was gonna be canceled, I'll be fine because then I can just like kind of catch up, I guess.
okay, no problem. Uh, I am just missing just one moment. Okay. Uh, Hi Vikas.
Hi everyone.
Vikas, we like Ashfaq, Mickey, and Sejal is here. Sejal is the uh, new because last time the Docker first session Sejal missed, so she
Okay.
attended a Git session.
Okay.
So I think before continuing to the next slides of Partha,
Mm-hmm.
we need to again brush up whatever I did in last session. That will be a good way because she won't be able to understand elsewhere.
Yeah, yeah, no problem. So you can continue with your slides, and then I will. Okay.
You please wherever you feel please
Yeah, sure, sure.
I'm sharing the slide again, but I will be Sejal, I will be not going at a slow pace. I will be going at a medium to like somewhat medium pace. So if you feel you have not understood anything anywhere, same with Ashfaq Miki, please stop me there and please question me. Fine.
Okay.
Sure.
Yeah.
Thank you. Let me start. Okay. So this is what we discussed last week, introduction to Docker. And basically, what is Docker, first of all? These are the contents of this slide. It's not important. Uh, what is Docker? Do you have any ideas, Angel? Say yes, I have.
Containers? Yes,
Yes.
yes, yes, yes.
Okay, so basically applications are of two types, monolithic architecture and microservice architecture. Microservice architecture means Docker based architecture. Monolithic means the traditional applications, like once an application is built, it's tested and deployed on a system, means installed on a system and run on a system. But in a cloud environment, it's all different. Do you want me to explain on this?
Yeah,
Because
so if
yeah.
is so I know like a little bit of microservices. So Docker, is it going to be more of a, is it going to be cloud based, right?
Wait, let me share my screen again and
Yeah, we can see your screen.
Yeah.
okay. Now let me share my entire desktop. Okay, I shared my entire screen. So uh, uh, for example, so we are not going into detail, just I am trying to explain you from a broad perspective. Like you see here,
Yeah.
hello.
Yeah,
Yeah.
yeah, I can.
So in a monolithic architecture, it's installed on a single machine. So like you can see, there is data interface, business interface, and user interface, means user is using the application. But in microservice architectures, or like in the first one, left side window, all the services, all the components of application are interrelated. If one component goes down, the machine won't work. For example, in a bicycle, if brakes go down or tire goes down, gets punctured, entire cycle will not function. In the same way, monolithic architecture will not function. And first and secondly, it's installed. It's a machine specific architecture installed on a particular machine only. It will work there only. But in microservices architecture in cloud based environment, uh, like we have local machines and we have virtual machines, there is a lot of difference. So so for different parts of the application, we divide it into different microservices. Each microservices is responsible for performing a specific task for that application, and it's independent of other part. For example, uh, like you see microservice in a red, green, and a light green and light blue. All these microservices required to run this entire application, but all these microservices are interdependent because these use microservices use containers. In other words, we are talking about Docker here, and there are some advantages, some disadvantages, and some features which will come across. So I think that now this is this slide is more clear, is it?
Yes, yes.
Thank
Thank
you.
you.
So what is Docker? What are basic commands? What are Docker files? So Docker is like this. First of all, consider this blue fish is just like your hardware, your hard disk. Above hard disk, there is kernel. Kernel is a basic operating system where, like, whenever your computer boots up, first of all, the kernel is activated, and then the operating system layer loads on it in a traditional environment. But in Docker, first of all, there is kernel, and then there are different containers. There is no operating system, but you can have different kind of containers, and each container represents a specific kind of task that is run in the system. For example, container 1 is running Tomcat, Java, and Debian. Container 2 is running SQL Server, .NET, and Ubuntu. Container 3 is running static binary and Alpine. So you can have as many containers as you want, and these container each container corresponds to a Docker image. I'll cover it in the next slide. So what is image and what is a container? Are you from a programming background?
No, more of a database, but I know just JavaScript and some
Okay.
Python. That's it. Yeah.
Do you know classes and objects in programming?
Yeah, that's Java. Yes. A
Okay,
little
okay.
bit. Yes, yes.
So just consider like this Docker image is just like a Java file, and Docker in container is just like instance of that Java file. So now this image or Java can be is a single file, but each time we run a different instance of this Java file will be created, right?
Yes.
I'm just telling you a comparison, like a similar analogy so that you can understand it better. It's not actually a Java file, but I'm just trying to explain like a Java file can be executed multiple times. Similarly, this Docker image can be executed multiple times to implement or to create multiple Docker containers.
Yeah. Thank you.
Then Docker containers are not VM. VMs are virtual machines. Virtual machine is a machine which divides your physical machine into logical components. So if you have a physical machine which has 8 gigabytes of RAM and you have made two virtual machines on it, means 4 GB RAM to one and 4 GB RAM to second. It means they are two different uh, logical machines, not physical machines. So easy connection to make fundamentally different architectures, means both the different virtual machines can be different. One can be Windows, one can be Linux, or and they fundamentally have different benefit because they are different, running different operating systems or different programs. And so Docker containers are not virtual machines. Virtual machine is dividing your physical machine into small virtual machines, and containers are instance of Docker images, like I told in you in last slide. So if you can see, like the left and right are almost similar, just difference in color and representation. So let's come to left side. Uh, there is it says virtual machine and Docker container. If you see virtual machine, first of all, there is host operating system like Windows, Microsoft Windows, and then hypervisor like Hyper-V. And once you install Hyper-V and activate in that Windows server, you can install Linux or any other guest operating system on it. In case you are aware, else I'm just letting you know. So on the Windows machine, Windows server, you activate the hypervisor and you can install some guest operating systems. They will divide the RAM and hardware resource and whatever resources you have on the machine into different parts. But in case of host, this Docker containers, which is on right side, colored diagram. So first of all, there is host operating system, let's say Windows, and then there is Docker engine. Docker engine basically is Docker runtime. The underlying architecture of Docker is Docker engine. And on top of that, you can run as many containers as you want, as many containers as your system can support in terms of memory and resources. So right now there are two applications, app 1 and app 2. The view, what is the basically difference between these two, virtual machine and Docker container, is that for example, if you have to run a program in, you are running a Microsoft Windows on your server, Windows server, and you want to run a program that needs Linux. In that case, you have to run, first of all, you have to install the Linux operating system. So on hypervisor, you will in a guest operating system, you will install Windows Linux, and then you will run the Linux application. So for example, I don't know exact, or I'm not talking about exact. For example, we have a 4 GB RAM and Linux, this Linux operating system needs around 4 GB of RAM, 2 GB of RAM. So we will allocate 2 GB of RAM to this guest operating system. And for running that application, which hardly requires around 50 MB, we need at least 4 GB, 2 GB of RAM, because this is a requirement to run that operating system, Linux. However, in uh, in Docker containers, if an application needs only 50 MB, it will only need only 50 MB or 5 MB or whatever, because all the libraries and DLLs and all the software, hardware, whatever dependencies that application has, it is coupled into the code, into the Docker Docker image, and every instance of that Docker image represents a container, and container will e- exactly take like 40 MB or 50 MB or whatever required MB is of memory. It will not waste all the MBs, all the memory, like 2 GB of a memory just to install Linux. It will not take that. So this is advantage of a Docker container. Please ask your question. I went too fast. In case we have not understood anything, please ask.
No, I think I got the gist of it. I see the benefit of using Docker versus virtual machines.
Thank you. So let's come
Yeah.
next. These slides are uploaded on the Teams. You can download. So what is a Docker? Docker is basically a lightweight, open and secure platform. Lightweight, I just told you how it is lightweight. It does not need entire operating system. It only needs the components which that particular program needs to execute. Only those components it needs. It runs natively on a Linux or Windows server, runs on Windows or Mac. So basically Windows operating system, Linux and Mac. It runs on all. and it relies on images and container, and containers are nothing the instance of that images. Whenever that image is run, the container is created. Okay. So using Docker build ship run workflow, so you can run the you can build the Docker images. You can whatever images you build, you can create and store that images, and you can and after that like uh, images are created, stored, or shipped. Then on the target machine, you can simply run those images to they will create they will produce some containers which you can run and execute on whatever system required. So on the top you see there is developers and there is IT operations. And if you combine, it becomes DevOps. Means there is development and there is operations and there is a synchronization between development and operations. And that's why it's called DevOps. So we are not treating development team as a separate team and operations team as a separate team. We are combinedly created one team which is called DevOps team. So if you want to customize and create your own Docker image so that you can execute your own special programs in a specialized containers, and you can write the code for it and implement that. So some Docker vocabulary. I told you what is Docker image. Basically, this is the code which represents a full application, and container is an instance of Docker image. So in this language, it says the standard unit which the application services resides and executes. Docker engine is the underlying architecture for the Docker, and it creates, ships, and runs Docker containers deployable on a physical or virtual or host locally in data center or cloud service provider. And what is registry? Registry is basically a cloud or server based storage and distribution service for your images. For example, on cloud, for example, in your local system, you have your hard drive to store all your data. Similarly, if you have to store the Docker images on cloud, we have Docker registry for that, which is called Docker Hub. So these are some basic Docker commands. So when you install Docker, you can execute the commands in command line like CMD or in PowerShell. So I just opened the PowerShell. So my Docker is installed on the machine and it's running. So I can execute these commands. For example, uh, Docker image pull node latest. So let's start from the second command, Docker image ls. This command basically lists all the image. So it says, OK, you have one image called doc getting started. Instead, if I also write Docker images, this will also do the same thing. Thus, the difference between two commands is like the syntax. Some old command, some old version of the command and new version of the command like that. Then Docker container PS is this basically you can also say Docker PS. This command tells you which total containers you have running in the system. And I see no container, but I want to see which all containers were running. So now it shows, OK, these are the all containers which you run in your system before, which are not running right now, but you run in the system before. So Docker PS minus A. And similarly, there are a lot of other Docker commands which we need to practice. And I'll tell you how to practice, because in this session, we cannot practice. I can just demonstrate, but you have to do some homework and I'll let you know how you can do that. So this is a Docker file, instructions on how to build a Docker image. So in order to build a Docker image, you need a Docker file. This is like a syntax. and looks very similar to native commands, important to optimize your Docker file. And Docker container versus Docker volumes use cases. So this is a Docker file and okay. So if I will run any image, first of all, what this system will do is Docker pull nginx latest. So first of all, the system will check, okay, do I have this nginx in my system or not? Now it says no, I don't have. Now it will start pulling from library, means it will start pulling this image from the internet so that it can be like it can create a copy of this image in the local system. And now it says pull complete, means the image is completely pulled from the internet. And this is the that particular numbering for that image and downloaded newer image for. So we can do something like this. For example, Docker. For example, let's pull the Ubuntu image. Hello.
Yeah, I'm here. I'm here.
Okay, okay. I just mean to say I'm not doing the session alone. Anybody else is also on the call. So okay. So now what? See what the system is doing. Using the default tag latest. See all the messages. Then says pulling from library because it doesn't found in my system. So it's pulling from internet. Now it's downloading. Its downloading is complete. Now it's extracting the image which it downloaded. And now it says Ubuntu latest. Now I have this image in my system. So volumes mount a directory in Linux, you have to mount a directory. Similarly, in Docker, volumes mount a directory on the host into the container at a specific location. And these can be used to share data between containers or directory persists after the container is deleted. Container is deleted, but directory still persists and unless you explicitly delete it and can be created in a Docker file or CLI. And why we use volumes? Just to mount local source code into running container, improve the performance and data persistence. Networking I have not covered in this slide. Docker Compose, yes, you can create your own images using Docker Compose. So build and run one container at a time, manually connect containers together. Means you are running, for example, 3 containers, then they are connected together using the same source file. You can do that. Must be careful with dependencies and startup order, like which container should start first and which should start second, and what is the dependency in terms of resources. So we used a .yml file. We also use the YML file in another application. I forgot its name. So single command to deploy entire application means you write all the application in the YML file and then deploy it. Handle container dependencies, work with Docker Swarm, networking, volumes, universal control plane. So this is the file, YML file. This is a syntax and structure. It looks like this. And scale container Docker Compose again for creating your own kind of images, customizing. And now if you go here, the first slide which is uploaded. So these are some prerequisites which you need to, these are all mentioned in a separate document also. You need all these prerequisites. And for example, first of all, you need to ensure the hardware virtualization support is enabled. There is a link. Install WSL. There is a link. Sign up for Docker Hub. Go to this website and just like you sign up for LinkedIn and Facebook, you sign up for Docker Hub and download Docker Desktop for Windows in case you're running the Windows in your desktop. Please download this. detailed instructions are there in a separate document along with this, and git bash java IDE. You all do all this, and then like these are the same command docker version to check which version of docker we have installed. Docker version. Is it visible or font is small?
Yeah, can
Yeah,
you increase?
yeah, it's hard to
I try.
see.
I'm not sure how to increase the size of.
Yeah, just click control and scroll up.
Okay.
Control and scroll up.
There is another way to increase the font size, but I'm not sure. If I'm doing right click, it's running it.
No, just control and scroll up.
Yeah,
You
that
don't
I
need
did.
to. Okay. Okay, no problem. This is good.
So, so Docker version, it tells you about the like detailed command, detailed version of Docker. And if you want to check it in short, you place a hyphen and run. It says Docker version 20.10.2, build this. And similarly, Docker PS all we already did. This is for running this image. For example, I want to run Ubuntu or this getting started. I have both of these in my Linux. I mean, downloaded to my system. So 8080 is port 80 of the system and port 80 of the container means the Docker which is running. And minus D means detached. So I will also like share the cheat sheet in which all these commands will be given. But the better thing is you start going here. It's docs.docker.com. This is the Docker website, and I go here. It's Docker desktop. Like if you want to really want to learn Docker, go to overview, Mac, Windows, dashboard, whatever facts, and like if you go through this way, you will be able to master this Docker. It tells about everything, Docker Compose, Docker Hub, everything. So docs.docker.com is the main command. Let me paste it here. Second, there is an also shortcut to learn all these commands, and that is if you go to the second slide. Let me go to the first slide. Okay, so start up the app image that was just built. Docker run getting started. So if I go here and put it here, it will start. Maybe there may be problem with the port number. Unable to find. Okay, let me make it port 80. Vikas, do you have any idea why it's not running?
Let me check what it is saying. Respond demand pull repository does not exist. Okay. Just don't move it. Don't move it. Don't move it. Okay, so what you need to do, this is the wrong command. Just click up arrow
Hmm.
and go before getting started. Okay, and just put docker, just write docker and slash. No, go back. Yeah, slash. Yes.
Backslash or forward slash, or is it okay?
Yeah, this is the right one.
Okay, so I need to change the port number 80 right here.
Uh, Port number is 80. Instead of 3000, you need to put 80
Yeah, this is
on right side.
right side. Okay.
Yeah. On left side, you can put any open port from your system. Yeah.
Okay. Now this is done. Now open your web browser to HTTP localhost 3000. For example, I go here. So, Sejal, can you see here? See here?
It's still very far, a little bit. Are you? Yeah. Yeah, I can see. Thank you.
Okay. So I just implemented the commands in the tutorial. I just changed the command was like 3000 is to 3000. I made this 80 and Docker dash getting started. So this was the command which I originally run. You can note down this command or take the screenshot.
Yeah. Can you just change it to into documentation so it will be better for next time? Yeah. Just change
Yeah.
it into documentation. Yes. Yep.
So I have not touched anything, but just added a line, right?
Yes. Yes.
Okay. So when you run this command and then run this localhost 3000, it will be something like this, getting started our application, and you can better, it's theory and practical combined. So you can follow this. This is complete tutorial and you can follow this to learn Docker.
Perfect. I will do that.
Thank you. And after this, you can also go here, go to the chat window. Where is it? And go to docs.docker.com and you can click on get started. Here it is. Like, so let me also place this link here. You can browse these links to understand and learn Docker. Fine, I think nothing is out of the page. Something is out of the page, so
Yeah. No problem. You can adjust that offline. Yeah. Okay.
fine. I hope it's visible, right?
Yes. Yes.
So
It
these
is.
are the extra commands you can run and get started. Fine. Okay, so moving ahead, like Where is my file? Okay, so this is all. I think we are done with that PowerPoint, first one that I closed. And do you have any question?
No, I will. No, thank you so much for the explanation. I'll go through the whole tutorial. Yeah.
Right. Couple, do you have one more talker session, or it's going to be API?
Uh, well, I think Partha can decide on that
Sorry?
because Partha can decide on that because he also has API session. So I'm not sure how long will it take. And in case there needs to be any extra session, he will like manage on that. Like,
Yeah. So
yeah.
if you need the extra, just let me know so I can extend the meeting link and everything.
So this is a cheat sheet for Docker. You will find on internet many cheat sheets. This is something what I have from GitHub, github.com cheat sheet. So I can share you this link. You can check that.
Yeah. Vikas, will you could say something?
How much time we have for this session?
This one is usually 1 hour. So that's 7 each week.
Okay, let me take over, and we have few minutes, so I can show something very interesting.
Sure. Let me close it from my end.
Okay, are you able to see my screen? Yes, no, yes, no.
I see the out, but it's a blank screen right now.
Okay, this is disaster. Okay, so okay. So Kapil mentioned about Docker Compose file and those things in a last session, like today's session. So this is what Docker Compose file looks like, and is it visible or it's
It's very far.
very far? Okay. Uh, to increase the font in this. Okay, let me open in Notepad then. Mm, sorry. Now you are able to see my screen, or it's just blank?
It's still blank.
Okay, maybe now.
Yeah, we can see it now.
Okay. So this is the format of Docker Compose file. Okay. So first of all, we need to mention the version. It should start with anywhere like version 2 or version 3. Version 1 is outdated, so nobody is using now, but version 2 and version 3 are still very popular. And the difference between version is the format. So if you put version 3, some of this command might not be identified by Docker daemon if you are using version 2. So that is the main difference. So the first thing is you need to mention the version. Second thing is services. Services means you can consider as a database or any application or any kind of storage. S- So that is include the services. So currently we are using two services. So this is just service name, database, and WordPress. And we need to define the image for each services. So the database services is using MySQL image, and WordPress is using WordPress image from, and these images are pulled from Docker Hub. So in Docker Hub, they have already officially published image, so they can use that. And after that, we can define volumes and some other behavior and environment variable. And this is the nature of a single container. Okay. Okay. This is the nature of single container, and this is the nature of the second container. So let's see now. Let's go to terminal. I know it's too small for you. Okay, so currently I'm running 3 container. Just don't worry about getting started, but these two. So let me put it down first. Docker compose down. Okay, permission denied. 1 second. Okay, so I set it off. So if we will see now, we can see only one running container. So if you wanna run this setup, you just need to do, give me a second, please. Yeah, so if you wanna run this application, you just need to type Docker compose up and Docker compose up. Okay, why this is bothering me? Okay, let's do it here. Compose up. And okay, so it will run all the containers. It will create a network. It will create the database. It will create this one container named with Docker database, another container with Docker WordPress, and network, and these are the live logs. And by running this thing, we can easily create a WordPress website, and that is here. Let me show you that. First, let's see in which port it is running. So if I'll open new container and if I'll type docker ps, it will give us a detail. So WordPress is running on port 8000 and MySQL is running on port 3306. So let's check on port 8000. So okay, localhost and 8000. So this is a brand new instance for WordPress, and you can set it up and you can run your website on this. So this was the smallest example, the power of Docker, and you can run as many as WordPress on a single server. So the benefit of Docker is another thing is like you can do virtualization and you can map the port. So one WordPress website you can run on port 8000, another on port 7000, and another on port 6000. So that is the power of Docker. And if you are on like a Windows system or Linux system, you can just run one WordPress website or any application on single port. Yeah, and I guess we just passed 6 minutes after that time. So yeah, Mickey, do you have anything now? Or
No.
yeah.
So you guys can just close the call when you guys are done.
Yes, and anyone has any questions on this? Kapil or
No,
Asfaq?
no.
Okay, no problem. See you on next week.
Yep.
Okay, okay, Vikas.
Oh,
Okay, Kapil, thank you.
Thank
Yeah,
you.
bye.
yeah. Oh,
Thank
Kapil,
you.
just talk to Pata about
Okay, sure.
next week.
Sure. Okay.
Bye.
Yeah.
Bye.
All right,
Thank
bye.
you. Bye.
Bye.